crash program, the AMCA.
A really ambitious project.
Totally. We're drawing on some detailed analysis to give you, our learner, a clear picture of what this is all about, the goal. Understand this major defense initiative without, getting bogged down in jargon.
Sounds good. Let's get into it.
Okay, so where does this AMCA story even begin? It wasn't just conjured up recently, right?
Right at all. The groundwork goes back to 2010. Actually, they were initially looking at a joint project with Sukhoi for a fifth-generation fighter aircraft, the FGFA.
I remember hearing about that. Didn't quite pan out, though.
Not fully, no. But the thinking for a domestic option, the AMCA, was already happening in parallel. There was a feasibility study back in October 2010.
Okay.
And preliminary design work started around 2013. So it shows they were thinking long-term about building their own thing.
Right, so even while exploring partnerships, they were hedging their bets, sort of planting the seeds for a homegrown fighter. And the key players are HAL, Hindustan Aeronautics Limited, and the ADA.
That's right, the Aeronautical Development Agency. They were driving it. By late 2013, they actually had 9 different CAD designs on the table.
9.
Wow, and these went through wind tunnel tests, radar cross-section analysis, all through 2014.
Standard procedure for something this complex, I guess.
Exactly. And by 2015, they landed on the, let's say, final basic configuration.
So what did that final design look like?
Well, it's a twin-engine jet. It's got these diamond trapezoidal wings, a V-shaped tail, and a single-pilot bubble canopy.
Okay. Now, people have pointed out it looked a bit like the F-35.
It does, yeah. And that's likely, a result of figuring out the best way to balance agility with being stealthy. Low radar cross-section is key for these fifth-gen fighters.
So it reflects global trends, basically.
Pretty much.
And strategically, what was the gap this was meant to fill?
The big goal was eventually to have something to take over from the Sukhoi Su-30MKI, which is a very, very capable aircraft.
Right, but often described as 4.5 generation, not full 5th gen stealth.
Exactly. Think of 4.5 gen as having, advanced electronics, maybe some radar cross-section reduction, but not the full stealth package, kind of like upgraded Super Hornets or Strike Eagles in the West.
So the AMCA is India aiming for its own F-35 equivalent, a lighter, maybe more modern option for those kinds of roles.
That seems to be the idea, yeah. A modern alternative built at home.
And what roles are we talking about? Just air-to-air?
Oh, much broader.
Yeah.
Air supremacy, definitely. But also suppressing enemy air defenses, SEAD, air interdiction, so striking ground targets, and even electronic warfare.
So a true multi-role platform from day one.
That's the intent. Versatility is built in.
Now, beyond just the shape of the plane, the tech inside, I heard some pretty ambitious stuff, like aiming for 6th gen internally.
Yeah, that was reported back around 2020. The idea was 5th gen stealth on the outside, but packing internal systems that lean towards 6th generation capabilities. Highly ambitious.
Hugely ambitious. How are they managing that? Seems like a massive leap.
Well, pragmatically, they've gone for a phased development, a Mark 1 and a Mark 2.
Okay, that makes sense. Break it down.
So Mark 1 will use quite a few foreign systems, get it flying, get it operational sooner.
Right, leverage existing tech.
Exactly. Then Mark 2 is where they plan to integrate more of the advanced domestically developed stuff, more Indian tech inside.
It's a smart way to do it. You get capability faster, but you keep that long-term goal of self-reliance.
Precisely. It's a trade-off. Speed versus complete technological independence from the get-go.
And speaking of independence and 5th gen stealth, that's the big one. What are they doing there?
Well, the whole design is shaped for low observability, obviously. The analysis points to HAL's twin-tail design helping minimize the radar signature. Plus, a big chunk of the airframe, maybe 30–40%, is composite radar absorbing material.
The RAM.
And, crucially, internal weapons bays.
Yeah.
You gotta hide the missiles and bombs to stay stealthy.
Of course. No sticking out and reflecting radar waves.
And then there are the air intakes. They're using something called diverterless supersonic intakes, DSIs.
DSIs, okay. What's special about those?
They have this characteristic S-shaped curve inside the inlet. The clever part is this shape basically hides the engine fan blades from radar looking at the front of the aircraft.
Because the fan blades are big radar reflectors.
Huge reflectors. Sometimes you can even identify a plane type just by the radar return from its fan blades. That's non-cooperative target recognition. So hiding them is a really big deal for frontal stealth.
Makes sense. Increases survivability quite a bit, I'd imagine.
Definitely. And they're also looking at other tech like flyby optics to save weight.
Flyby optics, so fiber optics instead of traditional wiring.
Exactly. Lighter, faster data transmission.
Mm.
And the radar itself is a modified version of their own ESA radar.
The ESA Active Electronically Scanned Array. That's top-tier radar tech.
It is, and they're planning to use versions of UDAM on other platforms too, like the Tejas, the Naval Fighter, even MiGs and flankers. Shows a commitment to that core tech.
This whole push for homegrown tech, it feels like part of a bigger pattern, doesn't it?
Absolutely. You can connect it directly to what Turkey's doing with their TF-KN fighter.
Right, another nation pushing hard for self-sufficiency in aerospace.
Exactly. Both India and Turkey are really focused on reducing reliance on foreign suppliers for critical military hardware.
And given their geopolitical situations, kind of caught between East and West.
It makes a lot of strategic sense. Relying too much on others can be, well, risky when things get uncertain.
Now, one area that's always a huge challenge for these programs is the engine.
Ah, yes, the engine. That's often the toughest nut to crack.
And the analysis suggests India is facing similar hurdles to Turkey there.
It seems so. Developing a high-performance jet engine from scratch is incredibly difficult. Back in 2021, there was talk of a joint venture for a semi-native engine. Okay. And then more recently, 2023, reports emerged about a likely partnership with France under this Horizon 2047 plan.
France. So Safran maybe. They have engine expertise.
That would be the logical assumption, yes. It really highlights that while airframes and avionics are huge achievements, mastering engine tech is another level entirely.
Most countries end up relying on U.S. or Russian engine tech historically, right?
Largely, yes. And it's not just about raw power,
No.
Reliability, engine life.
Yeah.
Those are just as critical, maybe even more so.
True. So where are they on the timeline now? The design phase is done.
Yes, design finalized by 2023 after about 7 years of work. And in 2024, a big step funding improved, about $1.9 billion for 5 prototypes.
5 prototypes. That's a serious commitment. When do we expect to see one fly?
Well, DRBO, the Defense Research and Development Organization, confirmed they expect the first prototype to be ready by 2027.
Okay.
And the first flight maybe a year after that, so 2028 perhaps.
Which is a bit later than some earlier hopes of flying. I think there was talk of 2024, 2025 flying.
Yeah, those were earlier projections from around 2020. Timelines often shift with projects this complex.
Understandable. And what engines will these prototypes and the first production jets actually use?
So the Mark I variant will use 2 General Electric F414 engines. Those are well-known, reliable engines. Around 90 kilonewtons of thrust each.
The same engine family used in the Super Hornet and Grippeney, I think.
That's the one. A proven power plant. Then the plan for Mark II is to switch to that more powerful, hopefully domestic or joint venture engine, aiming for maybe 110 kilonewtons.
So they're using a known reliable engine first. Again, pragmatic.
Exactly. Get the airframe flying, test the systems, use an engine works well.
And what about actual production numbers? When might we see squadron service?
Current plans target the first production AMCA rolling out in 2029.
2029.
Okay, and the overall goal is around 125 aircraft.
How would they be split between the Mark I and Mark II?
The idea is 2 squadrons equipped with the Mark I initially,
Okay.
and then another 5 squadrons getting the more advanced Mark II version later on.
That's a significant number. 7 squadrons total planned.
It shows they intend for this to be a core part of the Indian Air Force.
Let's talk performance. Obviously, a lot is still under wraps. It's still in development.
Very much so. Anything specific is likely classified, but we can look at some publicly reported claims, maybe from sources like Jane's.
Okay, what are the claims? Supercruise capability.
That's anticipated, yes. Being able to fly supersonic without needing the afterburner blazing, big tactical advantage.
And top speed.
The claimed figure is Mach 2.14.
Wow, okay. If that holds true, that's faster than quite a few other 5th-gen designs, like the F-35, KF-21, even the Su-75, apparently.
Yeah, it's up there near J-20 territory, which is claimed around Mach 2.0. Again, these are claims for now.
Understood. Service ceiling.
Around 65,000 feet, which is pretty standard for high-performance jets.
What about range? That's always crucial.
The claims here are quite impressive. Ferry range over 5,000 kilometers.
Okay, that's long legs.
And combat range supposedly around 1,600 kilometers. That would put it roughly on par with the Su-30MKI, the flanker, and potentially better than the F-35 or KF-21 in that specific metric.
Interesting. And weapons load, how much can it carry?
Reported total capacity is up to 14,300 pounds. But critically, the internal capacity for stealth mode is around 13,300 pounds.
3,300 internal. What could that hold?
Hypothetically, maybe 6 smaller bombs like MK-82s, or perhaps one larger MK-83 and a couple of MK-82s, plus air-to-air missiles. And then you have external hardpoints for another 11,000 pounds if stealth isn't the top priority.
How does that compare, say, to the Su-30MKI it might replace, or an F-35?
Well, the Su-30MKI can haul around 18,000 pounds total. The F-15E is a beast at 23,000 pounds. F-35 is also around 18,000 pounds total, so AMCA's total is a bit less, and the internal is smaller than the F-35's.
Does that smaller internal bay limit it significantly?
Maybe not as much as you'd think. The analysis compared it to how F-16s are often used. They don't always fly with maximum theoretical loadouts. Mission effectiveness depends on the specific task.
Right. And what about the weapons themselves? Any focus on Indian-made ordnance?
Definitely. It's planned to carry indigenous PGMs, laser-guided bombs, air-to-ground missiles, and especially the Astra family of air-to-air missiles.
Astra. Those are already in service in some forms, right?
Yeah, early versions were adopted around 2017. They're developing more advanced infrared and active radar-guided versions, specifically with AMCA in mind.
And looking even further ahead, I saw mentions of some really futuristic stuff.
Oh, yeah. The wish list includes things like integrating drones, both swarms and loyal wingman types, directed energy weapons, hypersonic missiles, even high-altitude platform systems, or HAPS.
So really planning for the future battle space.
It points to a very long-term vision for the platform's evolution.
One interesting design choice is the single-seat configuration,
Yes, just one pilot.
which is historically normal.
Mm-hmm.
But we're seeing a trend towards twin-seaters in some modern fighters, like maybe the J-20 or the KF-21 has a twin-seat version planned.
That's true. Traditionally, you had the pilot and then the RIO radar intercept officer, or WSO, the WISO weapon systems officer, to manage the complex systems.
Exactly. And today, the amount of information must be overwhelming. You got targeting pods, complex electronic warfare suites, advanced radar modes, data links, maybe controlling drones, networking with ground and sea assets.
It's a huge amount of data and tasks.
So the question is, can one person really manage all that effectively and safely, especially under the stress of combat? Or is two crew members actually better for handling that cognitive load?
It's a really valid question, and different air forces are coming to different conclusions, it seems. It's a significant design choice with big operational implications.
So wrapping this up, the AMCA project is, well, incredibly ambitious, kind of like the Turkish TFK program you mentioned.
Very much so. Both are trying to replace legendary aircraft.
Wow.
The Flanker family for India, the F-16 for Turkey, with their own designs, starting pretty much from scratch.
Which are aircraft with decades of development and combat experience. That's a high bar.
It really is. It's commendable, the ambition shown by India, Turkey, South Korea too, trying to leapfrog or at least match these established players with homegrown efforts.
The challenges must be immense. But seeing prototypes being built, flown in some cases, it really feels like a shift is happening.
Definitely. The next decade or so is going to be fascinating to watch as these domestic fifth-generation projects mature.
This deep dive really shows the sheer scale of the AMCA program. It's not just about building a plane, it's about building a whole industrial capability, right?
Absolutely. It signals India's determination for self-reliance in a really critical high-tech area. From the design philosophy, the tech goals, the inevitable challenges, it's a massive national undertaking.
And hopefully, for you listening, this has given you a solid, clear understanding of what the AMCA is all about without getting lost in the weeds.
Yeah, hopefully it's been insightful.
So here's something to think about. Given everything we've discussed, the complexity, the global competition, what do you think will be the single biggest hurdle for India to clear to make AMCA a true success?
And maybe flip that around. If they do succeed, what could be the biggest long-term impact? Not just for India's military, but maybe for its entire technological landscape. Something to ponder.